Hello, hello, welcome back from lunch. So I believe our next speaker requires no introduction. He's the founder and chief scientist of Dfinity. Dominic, the floor is yours.
Boo. Okay, it works. Hi. All right. Uh-oh. There we go. Hello, everyone. Thanks for coming to my talk. Today, I'm going to talk about building on the internet and what we're doing at the Dfinity Foundation and what our mission is, what the internet computer is, how it makes a difference, and perhaps where it's going. So I work at the Dfinity Foundation. We're a not-for-profit. The foundation was created end of 2016 to sort of carry a project that really began in 2015. We're probably one of the biggest crypto projects in Switzerland. We have about 270 people worldwide, 140 people working full-time from our Zurich Research Center. And we have an absolutely incredible team. I think we're the biggest employer of Google research people, for example, in Switzerland. I think we have the biggest sort of team of sort of famous and well-cited cryptographers in the world, like bigger than you'll see in large companies. And I'd probably say, Dfinity is one of the strongest teams in tech, full stop. It's an incredible organization, and it's been working away for many years on this internet computer thing. So the internet computer, people often ask what it is, and I think this is where things can get tricky. It is actually a blockchain, but it's got a completely different architecture. It works in a completely different way, and it's powered by a lot of sort of moon math and clever tech. And today, it's actually the world's highest usage blockchain. Perhaps not in terms of things like TVL, but the current focus tends to be on running Web3. Today, I looked at it, it's doing about 250,000 Ethereum equivalent transactions a second. 250,000 Ethereum equivalent transactions a second, which is an absolutely stunning number. You can understand the internet computer in the context of the evolution of crypto. In January 2009, we got digital gold in the form of Bitcoin. And that was an obviously absolutely seminal advance in the sort of internet space. And then 6 years later, in the summer of 2015, we got smart contracts from Ethereum. And now all of a sudden, you could actually keep software and data and run that software on the blockchain. And that, again, was another seminal advance. And scroll forward another 6 years, and the internet computer appears, and now you've got a kind of crypto cloud. You've got a platform where you can run smart contract software at scale equivalent to traditional tech. And one of the aspects of the internet computer is it's multi-chain, natively multi-chain, and that's kind of rolling out at the moment. And, in combination with other blockchains, the internet computer creates a world computer. And that's what it was designed to do, what it was conceived to do back in 2015. And this world computer runs software systems. And software systems are the foundation of our society, whether it's social media or the supply chain systems that move goods and services around. And so the world computer is really like new foundations. It's new horizons, new dawn. If you change the foundations of society, you can see some pretty amazing things happen. And zooming out a bit, because the purpose of the internet computer and the mission is really much more than just being a sort of blockchain mission. And the purpose of the internet computer is to advance the internet from being a public network that connects everyone and everything to also being an infinite crypto cloud on which the world can build. So we want the internet to be the place people build. We want the internet to be the platform people build on, rather than centralized systems. So you can kind of see this in terms of the general arc of tech and the development of the internet. If you went back to the mid-1990s, there was actually a debate going on about how people should connect. And you had America Online, Microsoft and Oracle proposed the information superhighway. And they said, look, we're going to create this walled garden, which is going to be much safer than the internet. And we understand what the customer wants, so we're going to curate all the content for everybody. That kind of disappeared. That idea disappeared pretty quick. People wanted the open internet. They didn't want to be captive customers of a big corporate. And the openness of the internet and the permissionless nature of the internet meant that it provided a free market. And that's why we got all this incredible economic growth and innovation and social freedoms. So I think the world computer that's being created by this technology should be seen within the same context. And in some ways we see an equivalence between the internet and information superhighway, world computer and Amazon Web Services. I think a lot of, one of the challenges of understanding, where this technology is going and what this is about is understanding what, for example, even Ethereum gives you over the technology that existed before, and what the underlying mathematics that creates a blockchain delivers in terms of practical, real-world value. And it's all about smart contracts from 2015 on. And smart contracts have these absolutely magical properties. It's a new form of software, completely new form of software. So smart contracts are tamper-proof. You don't need firewalls, for example. They're unstoppable. You don't have to worry about a smart contract stopping. They're autonomous. You can make them run without a human controller. You can process tokens. You can process value-like data. They're composable. And they're often composable between different parties who don't have to trust each other, and they're borderless. And that's why Ethereum was so revolutionary. And the Internet Computer introduced a new form of smart contracts called canister smart contracts. And these come with some additional properties. They're multi-chain, they're scalable, they're efficient, they're low cost, and they run extremely quick, and they can even process the web. And that gives you this kind of crypto cloud world computer functionality that we've been talking about. So I'm going to focus a little bit on Web3 here because that's the tip of the spear. Like enterprises will move on to the world computer more slowly. Tamper-proof autonomy, like true autonomy, like when the whole thing runs on the blockchain, you can do much more interesting things, and particularly with relation to tokenization. So this is something I want to draw your attention to, hot or not. It's a kind of tokenized TikTok, all right? And it's growing pretty quickly at the moment. It runs on the Internet Computer. You can bet hot tokens on whether you think a video is hot or not. And that helps, obviously, with content recommendation. It's alpha, it's super early, it's got a long way to go, but it's still engaging and fun because of the tokenization. Content creators, or rather the creators of viral content, are also being rewarded using hot tokens. And the content moderation is done by the users themselves. Now, this needs some improvement, but it's a very, very interesting thing. And what you're going to see is that the Web3 services of the future are going to run on the chain, not on Amazon Web Services. So there's, sometimes we get muddled up in blockchain with language, right? And we've done some surveys, and there's a lot of confusion. Like you hear people saying it's built on Solana, built on Aptos, built on Sui, built on... Being built on something in blockchain doesn't really mean that. What it means is that you built something on Amazon Web Services, and you've kept an NFT or a token on the blockchain, right? That's generally what the language built on a blockchain means. It really means built on Amazon Web Services, token or an NFT on the blockchain. When people talk about built on the Internet Computer, it means something very different. It means that the whole thing's running on the Internet Computer, and you can control it via DAO. And this means you can founderize your community by giving them governance tokens. You can turn your community into an industrious workforce, right? So if you look at hot or not, people are getting rewarded in a way if we're helping with content recommendation by betting on which videos will go viral, which won't, helping with content moderation. People creating videos are receiving tokens. And the community fundamentally owns and governs these next generation Web3 services. OpenChat's another example. It's a 100% on-chain app. It's actually running under the complete control of a DAO, which we'll get to. The accounts are wallets, right? So if you have a messaging account on OpenChat, that's actually a crypto wallet. And you can send Bitcoin with a chat message. You can say, hi, hey, here, have happy birthday, have 10,000 Satoshis. And there's no interaction with a crypto wallet like MetaMask or anything like that. You can literally just press a button, press send, and send crypto. And it's multi-chain, obviously, because you're able to send Bitcoin, and shortly the integration with Ethereum will be complete. There's no bridge, it's a direct network-level integration. You'll be able to send any crypto pretty much on Earth, NFTs, ERC20s, whatever you want. And in this thing, I should be clear, like every single message is a transaction, and that's why you're getting such large transaction counts. So lastly, I mean, we're probably, well ahead, in the internet computer ecosystem is well ahead with respect to Web3. There's no other blockchain on Earth that can actually host a Web3 service on the blockchain, right? It's the only public platform that can do it. But DeFi, is slightly more complex because smart contracts run in parallel on the internet computer and a bunch of other things. But it's sort of kind of catching up now, and you're beginning to see some new stuff. So this one, ICDEX, is really interesting. I don't know if you can see it, but can you see, this is, if you look in the URL bar of this browser, you'll see like some crazy number. That's because the browser is talking directly to the smart contract, right? This is an order book exchange that provides functionality equivalent to, NASDAQ, dare I say it, FTX once. The difference is that it's a smart contract, and this will be controlled by a DAO. All the updates to the code will be passed through that DAO transparently, completely tamper-proof, unhackable, doesn't need a firewall, doesn't need a security team, and it's providing the same functionality as CeFi exchanges. And so this is a big advance. I'd probably call it DeFi 3.0, and that's the kind of stuff that's coming on the internet computer. So finally, DeFi is coming to the internet computer. There's a kind of sort of grassroots developer army that's building things on the internet computer. And all kinds of exciting things exist, and I won't try and enumerate them. There's a lot of social media. Increasingly, there's people experimenting with DeFi and other things too. Obviously, metaverse and gaming and so on. But the approach generally is, build something that's fully on-chain, and people's objective is to get to this full decentralization where you control a service by a DAO. So just something I want to draw your attention to, because sometimes it's difficult to grasp fundamental innovations and why they're so important. When I was talking about smart contracts, I listed all these different properties like tamper-proof, unstoppable, autonomy, and so on. But just think about the tamper-proof one. We live in a world where systems are being hacked all the time or getting encrypted with ransomware, right? Like none of these Web3 services I talked about just now has a firewall protecting it or a security team. So if you think about OpenChat, for example, it's like SocialFi, right? Your chat account is also a crypto wallet. When you send a chat message without any interaction with a wallet, you can send crypto. So the crypto is being custodied inside your chat account, but because it's a smart contract, it can't be hacked. It doesn't need a firewall, doesn't need a security team, albeit you may have audited the code to make sure that there's no bad logic. So this is a sort of seismic, fundamental advance in computer science. I'm going to talk about open source to open internet services. So in internet computer lingo, OpenChat was the world's first open internet service because it's controlled by a DAO. But it's not like the kind of control you hear about generally speaking. It's not like where someone just puts a text proposal, everyone votes on the text proposal, and then the winning proposal, the idea is some developer goes away and implements the proposal. It's nothing like that. The internet computer uses a special kind of DAO, if you want it, called a service nervous system, and it's a complete framework. So one way of understanding this is, you start with open source, right? And open source projects, involve a source code control manager, and some human management to mediate access to the code, like pull requests and stuff like that. An open internet service is run by a thing called a service nervous system. It sort of takes the place of GitHub, but you get fully autonomous management. There's no human beings, there's no backdoors, and this is a key part of the internet computer vision. I won't talk too much about this, but a service nervous system DAO uses a system called liquid democracy, and you get all these kind of advantages: transparency, security, autonomy, ownership, tokenization, fundraising, scale, right? Because if you're giving your community governance tokens oftentimes they'll help you with other tasks. So in the case of Web3, perhaps they'll help you with creating viral content or moderating content. So, the decentralization of a service can help you scale the human side of what makes that service interesting and a great place to be. And of course, you get reach because DAOs are borderless. So, Web3 often faces this key challenge. So just talking about the wider Web3 ecosystem. And, you've got a blockchain ecosystem, and you've got these centralized platforms, and then you've got Web3, right? And really, people's Web3 experience is mediated by those centralized platforms. And of course, not surprisingly, that's where hackers go, censors go, gatekeepers go, vested interests go. It's not borderless, and you've got to trust the developers. So, this is the typical architecture today. Your Web3 experience really is an Amazon Web Services experience. 99.99% of the compute happens there. And blockchain is just being used to store some tokens and NFTs. And even the content of the NFTs isn't on the blockchain. That's back on Amazon Web Services too. Sometimes behind IPFS, but it's on Amazon Web Services. So, users want to be in control of these Web3 services, but, they can't be, because really those Web3 services exist on Amazon Web Services. And obviously, Uncle Jeff, he has complete control. He can switch them off or do what he likes. The developers, who put the credit card in, right? They've got the username, password access to the Amazon Web Services account. They can arbitrarily modify data, code. They can switch it off. They can make everything disappear in a puff of smoke if they want. So, there is a problem with this kind of slightly mistaken language, like the service runs on this blockchain. And this is something that the internet computer can help Web3 address. So, here's Web3 without intermediaries, world computer controlled by a service nervous system. It runs 100% autonomously. Users can be sovereign. And, providing users with sovereignty is a key aim of the kind of cypherpunk dream and Web3 generally. Users are owners. They've got these governance tokens. They participate. They're founders as well because, maybe in exchange for credit for doing tasks for the platform, if we're talking Web3, like creating content and helping with moderation, they're receiving governance tokens. They're becoming founders. And of course, you can create much, much richer experiences when you can fully tokenize and you're not just stuck in a separate kind of wallet appendage, right? When the whole thing runs inside a smart contract, you can do really amazing stuff. But it's not just about, Web3. Web3 is the tip of the spear. I think like enterprises, we've already got some quite big enterprises experimenting now with the internet computer. There's actually some sort of government projects on it. And they can look at the Web3 on the internet computer and they can see, wow, you can build services with hundreds of thousands of users that never go down, right, never stop, and don't even need they don't have a firewall, they don't need a security team. So we actually believe that the future of enterprise systems is they will also be assigned to DAOs, like service nervous system DAOs, because you don't want to give one developer at your company the key and the ability just to take all your systems and data down. So you decentralize control within the organization by distributing the governance tokens. Instead of distributing governance tokens to tens of thousands of people or millions of people like you do in Web3, you're probably going to distribute governance tokens to 20 people. But you still get this semi-autonomous operation, so you're secure, there's no firewalls, you're unstoppable, no seam logging, no worrying about viruses and getting ransomware installed on your servers and things like that. So big deal. Mission, the mission of the internet computer is to sort of drive a blockchain singularity where most of humanity's systems and services are eventually sort of reimagined and rebuilt end-to-end on world computer. Last thing to mention, I think AI is going to be absolutely huge. You can't really separate AI and computation. It's going to be at the heart of absolutely everything. I mean, some people say by 2030 it'll 4x the productivity of knowledge workers and boost global productivity by sort of $200 trillion. So in the future, AI models are going to analyze all of our data, and they're going to generate, for example, all of our metaverse content. They're also going to be doing things that you may not imagine, like compressing media. So we've been working with people that use AI models to compress media. So you can reduce your Zoom bandwidth quite substantially. And so AI is going to be running on the internet computer. We're hoping to have AI compute units running on the internet computer by the end of this year, which is big. And for 18, 24 months, you'll have AI smart contracts. Crash course, I'm going to go very quickly and run over by a couple of minutes, but just so you can see it and you get an idea. Internet Computer Protocol is a crypto protocol that combines these things called node machine devices that are run by independent node providers. Internet Computer is not a proof-of-stake blockchain. Its best description is proof of useful work. It's hosted by a sovereign network of dedicated node machines, which are standardized hardware, a bit like, you know, how Bitcoin is created by ASICs. So it's not proof of stake. And these nodes are combined by the protocols to create subnet blockchains. And these subnets replicate and run canister smart contracts. And together they form a scalable and efficient virtual computer, internet computer. And you can interact with that computer from any web browser. As we've already discussed, you can use it to build anything. If there are any like Ethereum guys here, like people here, it's like, it uses a system called reverse gas. So the smart contracts actually pay for the transactions themselves. The entire internet computer network is controlled by something called the network nervous system. It's like a protocol, in-protocol DAO. Like all of the updates to the protocol go through this thing. There's no forking, there's no insiders, there's no coordination of miners or anything like that. It's what's known as an adaptive blockchain, and it's self-evolving through proposals. It also creates these service nervous system DAOs, which are used to create open internet services. I won't go too much on this, but you can authenticate yourself with a fingerprint. Here's something that's interesting. You can actually interact with the internet computer securely, knowing only a single 48-byte master chain key. It's powered by something called chain key cryptography. That's how a lot of this magic has been made possible. It's absolutely revolutionary. If you know this 48-byte key, you can interact with any node on the internet computer. Yet, of course, there's no private key in the conventional sense, otherwise it would be stolen. Internet computer smart contracts can interact with the outside world through outcalls. Lastly, I just want to talk about smart contracts can sign. So an internet computer smart contract can create public keys and sign for them. And that means that they, powered by chain key crypto, they can interact with other blockchains. And this is already running, so there's something called chain key Bitcoin, which people are beginning to talk about. I think you'll see more of that this year. It's an alternative to Lightning Network. You don't have to pre-stake any channel or anything like that. You can transfer Bitcoin in 1 second, 1 to 2 seconds, and the cost is absolutely negligible. The next thing's Ethereum integration, and you're going to be able to do things from Ethereum, like spin up a user experience from an Ethereum smart contract on the internet computer, spin up an AI, use these kind of more powerful, for example, DAOs even on the internet computer to control Ethereum smart contracts. All of that's coming soon. It's in progress, hopefully sometime in July. And that's it. Yeah, sorry for going over.